All right, welcome back. We are game 3001 in the winter 2021 semester at George Brown, and it's week 3, part 3 of our broadcast. We're going to be starting lab 2. So I'm just going to scroll down here. I just added a little slide here that does not include it in your slides, but this is kind of the goals for this lab. And again, they're not really complex goals. They're just I just want to make sure that we're on the same page when it comes to the stuff that we want to accomplish today. So one of them is I want to finish Seek, and I'll explain how that works. And the next part is I want to start obstacle avoidance. Now, when I say start, there's a lot of little piece parts to get this done and this. So that's why we'll start this part and finish this. So the rest, remember, is on you. I'm also going to do a combined look where you're going as well as seek. I haven't touched flee. That's for you to do, and that should be fairly straightforward. Okay, and the toggling, I'm kind of including it all at once. You need to toggle on seek and or look where you're going and arrival and all that kind of stuff. And I've kind of combined seek together in one. So there's some work for you to do. I mean, I can't do it all, right, for you guys. So let's start off with the first piece. So I'm starting with last week's, kind of lab. So we're going to kind of go into GitHub. And if we go to George Brown, this is the one we did from the first class, but I'm going to grab lab 1B, this one here, and download it. And I've already done that, kind of in our framework. So let me just go there and show you where that is. Eventually, it's right here. So there's lab 1B. So if you want to wait for a second, I can put up, I'll call it lab 2B for you guys to start with. All right, so again, I'm just gonna unzip this, and it's right here, which is lab 1B master. We'll just call this lab 2B, and this is the lab we're gonna be working with today. Okay, there you are, and I can delete this one. So lab 2B, I want to put this up on GitHub, but first let's launch this in my Solution Explorer and see what this looks like. All right, so this is lab 2B. Let's put this into x86 mode so that we know it's going to work. Yeah, you can do that too, Dylan. I mean, it's complete. So as soon as I launch it, you'll have it. So let's put this up on GitHub. So I'm gonna go to Team Explorer. Actually, I'm gonna go to Solution Explorer, and I'm gonna right-click on my solution, and I'm gonna click on Create Git Repository. And when I do, it adds my solution to source control. So that's the first part. And then I'm gonna go to Team Explorer, and I'm gonna go to Home. And notice on Changes, there's no changes. But if I go to Home, Sync, then just like I showed you last time, there is this Publish to GitHub link. I'm going to click Publish to GitHub, and I'm going to put up your I'm going to put this Game 3001 Winter 2021 Semester Lab 2B up on GitHub for you guys, and I'm going to share the link with you guys on Blackboard. Give me one sec. So if I go back up, and you can see that I've got this link. Here's lab 2B. And that's where we're going to start from. I'm going to copy this whole link. And I'm going to go to Content, and I'm going to add a new web link. And we'll call this Lab 2 Starter. This is for everybody, you and everyone else. Okay? So this is where you would start. So please download this if you're ready. Or you can start from what you had last week. It's up to you. The only difference is that this one will have its own repository. I recommend making your own repository for this one, a separate one, than the one you had last week. Okay. Fantastic. So we have our lab 2 starter, and what we have there right now is, if I run it, we have some good things and bad things going on, and we got to fix some stuff as we start. All right. So again, what we're trying to do is fix our seek and we want to make it smoother, and we're going to add some additional tools to have that happen, which is kind of an important piece. So let's take a look as I build, and hopefully you'll see what I see. If I press backtick, you can see that I have my this going. If I click start, you see just the ship kind of goes down in here, and this is kinematic. There's no smoothing, and the velocity is something that hasn't been adjusted. Let's make some changes to the project first. In docs, I want to go to README, and I want to change the README from lab 1 to lab 2. Let's save that. So that's the first thing I'm changing. So in the README file in docs. And then what I want to do is I want to start thinking about using a physics equation to move things around. And usually the physics equation, and I'm just going to close this down. The physics equation goes something like, if I was going to draw it out, right? It kind of looks like this. It kind of says that like when you want to add velocity, right? What I want to do is my velocity, I want to multiply by my velocity by time. All right, so that's my position. So what I do is something like take my velocity, right? My initial velocity and multiply it by time. And then what I want to do is I want to add 1/2 of an acceleration, right? The initial acceleration, multiply by that by time as well. So multiply that by time. And usually when we do acceleration, we multiply by time times time, which is time squared, right? That's how you normally do it. And then we add this into our initial position. So we say P initial plus this, and then you get what you have is the final position. So P final, this is the equation we're going to use, right? So P final is equal to, thus position final is equal to position initial. This is every frame, by the way, or according to time. And in the update function, we're going to multiply our velocity initial by time. And then kind of, I want to use this kind of equation to kind of smooth out how the object moves. So kind of like a physics equation for how this works. We also need to figure out orientation. So one of the things we have right now for orientation is it doesn't really point in the right direction. I want this to be normalized, right? So in other words, really, if you think about what orientation is, orientation should be, in a later version, equal to rotation, right? From a transform. So it should be like transform dot rotation. That's what normalization should be, or orientation should be. Right now, we don't have that. We're just kind of raw. So this is kind of what we're looking for some optimizations, right? As we're going forward. So I want to kind of use this formula to move. Right now, we haven't used this. And in order for me to use this formula, I need to define kind of a couple things. One of them is some kind of acceleration rate. So we need this, an acceleration rate. I need also, this is new stuff, so new properties. I need an acceleration rate. I need some kind of turn rate, all right? And the turn rate is in degrees, right? That's what I need. Acceleration rate is in units, whatever that is, pixels and whatever. So acceleration rate, turn rate. I also need to incorporate some kind of clamp for the max velocity or max speed. So I want to be able to clamp velocity, right? So that it doesn't surpass my maximum speed. So when I clamp velocity and max speed. Velocity right now is a vector 2, and I don't have a clamping function to do that, but I'm going to build one with you guys right now. Okay. So those are the things that I need to do before I start. So I have some work to do to get going. I don't have I don't really have this time in units. I could develop something called a delta time, right, which you've seen before, which is really the time in milliseconds between frames, right? That's what delta time is. So we can determine that as well. And this is usually, delta time is usually used as a scaling factor so that we don't spam, kind of speed and that kind of thing. Again, we'll see if we can use this thing and how this works, what it does for us, and we may make some modifications to delta time as we go forward. All right, so that's kind of some of the things we need to do to prep for the things that we want to do. If we have time, I want to also start obstacle avoidance, and that's when we to do this, we need an obstacle. And I know some people want to hear some collisions. We'll do some basic collisions if we have time. This is secondary. The primary thing, though, goal 1 is to make our movement solid and smooth. Okay, so let's figure out if we can do this. So let's do some prep. So the first thing I want to do, if I go back to my project, is I want to go into my core and I want to build some utilities again. So going into utilities, this time I'm going to build something called a clamp, but I want my clamp to be for vectors. So I want to build static. It's going to return a GLM vec2. We're going to call this a clamp. It's going to take, again, a vector2 first, right? So that's what I'm going to do first. And then after the vector2, it's also going to take some kind of maximum length. So I'm going to say that clamp GLM vec2, which is going to be some kind of vector. And then it's going to also take a max length. And the max length is going to basically say that, hey, I'm going to clamp this vector to a maximum, so a magnitude, whatever that magnitude is going to be. Okay. This is going to be an overload of the clamp function that I already have. So I'm adding additional functionality, just like I did with the lerp, and I also did with the random range. So I've got those two functions in there for additional functionality. So let's add that in. So I'm going to go to clamp, and I'm going to add in generate implementation. And there's my clamp implementation. And what I want to do with the clamp, I want to talk about this for a second, is let's think about some kind of auto method that is, I want to think about this as square magnitude. There's my square magnitude. And we're going to say that that is equal to the squared magnitude, which I already defined here in the utilities, of the vector. So I'm going to say whatever that vector is, and remember what squared magnitude is. It's different than magnitude. Magnitude is using square root. Squared magnitude is not. Squared magnitude is taking the squares and not the square root. Okay, so that's the first thing. I want to get the square magnitude. And then I can check to see if my square magnitude is greater than the max length, so multiplied by max length, there's the same square. So we're comparing the same length. If this is greater, if my square magnitude is greater than the maximum length, that means like the maximum length would be the max speed in this case, then I want to clamp. That's where I want to clamp. Otherwise, if it's not, then just return back the vector, right? I don't want to do anything if I haven't surpassed my maximum speed or whatever. I want to return back the original vector. Okay. However, if I did surpass the maximum speed, I want to get the magnitude, and I want to say that the magnitude is the square root of the square magnitude. So there's my way of doing this, okay? And what I want to do then is I want to use a couple of normalized values. So normalized x is going to be equal to the x value divided by the magnitude. So I'm actually normalizing. And normalized y is equal to the y component divided by the magnitude. And then what I'm going to return is a new vector2 with where I passed in the normalized x multiplied by the max length, and then the normalized y. So I'm going to denormalize it, if you will. First normalization, and then I'm going to multiply it by I'm going to clamp it to the max length. That's what I'm doing, right? So what this does, it'll return a vector, a new GLM vec2 is what I want. it'll return a vector that is exactly, worst case scenario, the magnitude of this. Okay, that's what it is. So whatever I pass into it. So if I pass an example, a maximum speed of 10, then what this is going to do is calculate to see if the square magnitude or the magnitude, the length of the vector is greater than 10. And if it is, it's going to clamp it at 10 and return that new vector. So again, I will. So util.h, all I did with util.h was I created a new clamp function. And the new clamp function is an overload of the other clamp function, which clamps, whatchamacallit, a floating point number between two values. So between min and max. So if I want a number never to escape min or max, then I can clamp it. But clamping a vector is different. And what I want to do with when I clamp a vector is I want to make sure that it stays within the maximum length or the maximum magnitude, if you will. All right, you can actually put that as magnitude. So that's what I'm doing. So if I go back to util, let's fix some of this that we're getting some, some kind of some suggestions from C, B Sharp or C++. So I'm going to do that. So it's going to add const to some of these things because it's probably going to want me to do const, and that's fine. So let's do that. And now we have our normalization. This is our clamp. We're going to be able to clamp a vector. So again, I'll say this this method clamps or constrains, like it says confines vector magnitude to the max length parameter. Okay, that's what it does. So that means it can't be, if I want to say that the maximum speed is 10, then I want to calculate what that maximum speed is, and I'm going to return a vector of that type. Okay, so we need that little utility function. All right, good. So utility is done. I don't need this anymore. I can get rid of it. And let's put this up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say, these are all the changes I just made. I'm going to accept those, stage those changes. I'm going to say added clamp overloaded clamp function for vec2s in util library. That's what I did. I'm going to commit staged. I'm going to say home, and I'm going to go sync, and I'm going to push this to GitHub. So you're going to have all that stuff up on GitHub. And so you have now my updated utility library for that thing. So sure, I can show you I can show that to you again. So if I go home, and if I go to, but again, it's up on GitHub, but if I go to Solution Explorer and util.cpp, then it looks like this. This is the clamp that I just made. And all I'm doing, as I said, like I'm clamping a value between a vector between, to a maximum. I'm constraining it to the maximum magnitude, if you will, that I pass into it, which is the max length. All right, so hopefully you've got that. Are you with me? Check mark if you're with me, guys. X if you're not. This is the first change because we need this little function. Otherwise, we won't be able to do what I want to do. I got one check mark. Thank you, Jacob. The rest, 2 check marks. Sorry, I got 2 check marks. Squared magnitude. This one is giving you an error. It shouldn't, because that, if you really want to be specific, you can put a util in there. You could say util and then squared magnitude if you want to do that, because that's where it's coming from. Squared magnitude is coming from down in here. It's actually something that I've already defined in here. This is my squared magnitude. Okay, so again, you could put it very kind of like a specific, explicit, calling util, but it's part of this whole library. So it shouldn't give you an issue. All right, so thank you for that. So that is the squared magnitude. And now that I've got this, let's go to the next part, which is I want to start modifying my ship, my spaceship, with additional properties that it's something that I want to add. So I want to go to, close this up. I want to go to game objects. I'm going to go to spaceship.h, and I have some properties that I have here. I have a destination, a target direction, an orientation, and a rotation angle and max speed. I want to add in here turn rate as well as a acceleration rate. I want to add those two things in. Let's put them in. So again, it's a float that is m underscore turn rate. So how fast? This is how fast an object will turn. How many degrees per frame, if you will. And then as well as m underscore acceleration rate, which is something that I'm going to multiply by my default acceleration so that I can increase my acceleration, kind of as a scalar every frame. Again, different ways of doing this. This is the way I kind of thought my brain up, so you might think of it differently, and that's totally fine. Things that we want up here, I want more getters and setters. So I set max speed, I might set the destination, I set orientation, but I also want to get orientation. Let's do that. So I'll say void get orientation. And when I get orientation, I want to not return void, but actually return a GLM vec2. Okay, so I want to be able to get orientation, right? I also want to set rotation and get rotation. That's cool, right? And let's put the getter before the setter just to reorganize how I've put this in there. I want to kind of get and then set, set rotation. I also want to get turn rate. So float get turn rate, right? And I also want to set turn rate. So again, it's void set turn rate, right? Where I want to put in the rate, whatever that is, as a float. And I also want to get acceleration and set acceleration. So get acceleration, it's the acceleration rate that I want. So it is a float type. So get acceleration rate, right? And as well as I want to set acceleration rate. So set acceleration rate. And you're going to see what I mean by that. Turn rate, thank you. Thank you. Thank you. And turn rate's good. Okay, so those are the things I want. And you see that there's 1, 2, 3, 4, 5 little functions we're going to define. But all they're going to be is getters and setters, so it won't take long. So what I can do is if I go to the top here where I say spaceship and I click on the little hammer, then it'll say generate definitions by declarations, and it'll suggest all the ones that I just made all at once. So I click finish, and then in the .cpp, it adds them all in one blow. There they are. So if I want to get, how did I do that? So back here, I went here and I went to this, and there was an option to here. I'll just redo it. Just undo. So all of these weren't here, and I'm just going to put them back in. Watch. So what you do is you go to spaceship.h, and if you go to the little hammer, it'll say something like generate definitions by declarations right here. It's a resharper feature. And then if I click this on and I click it, it'll give me all these. I want all these to be generated, and I'm going to click finish. And that's going to generate all those function headers really quickly. So get orientation. How do I do that without resharper? One at a time is the answer. Can't do that without resharper. Set acceleration. Yes, we did. Yes, we did. Let's modify that. So thank you for that. So set acceleration, we need some kind of new acceleration. I'll fix that. Acceleration. So whatever the rate is, actually it should be just rate is what it should say. So the acceleration rate and the turn rate. Okay. And then what I got to do is modify my acceleration. So it takes a, there we go. So that should fix it. Zach says, will I post all the changes at the end? Yes, I will. Nikolai, yes?
I'm sorry. You modified the get acceleration, not set. You see?
I'll be okay. Thank you for being so careful and watching. All right, so let's go on. So first I'll start with get orientation. So all we're going to do is we're going to return m_orientation. Again, in a future version of this code, we could just be setting and getting our rotation, because really rotation is x and y, and we can't really use rotation with x, y, and z. We're rotating around the z-axis, but you know, as an example, there is no x and y rotation, so it'd be more like an orientation change, right? Get turn rate, again, return m_turn rate, and same thing goes with set turn rate, m_turn rate is equal to rate. It's going to give me suggestions to make this const, and give me suggestions to make this const and make this const. That's just ReSharper's suggestions. I agree with these things. Get acceleration, again, we're going to return m_acceleration rate, and we're going to set the acceleration rate, m_acceleration rate is equal to rate. Again, this is going to make this it's going to make this wrong button. It's going to make this basically const, as well as this parameter const. That's what it's going to suggest. And I agree with those. So that is all my getters and setters. And I'm doing this, again, this is all prep. This is all prep for me, because I'm prepping to make sure I have all the properties that I need to make sure we get going on all the stuff we need. So get ReSharper, Ethan, get ReSharper, it's free, right? Like I said before, so that you can have it ready for the next time. All right, so cool. So we've got all this stuff. We added all this stuff in one step at a time, and look like orientation can use a bit of a change too. Let's modify this. Let's keep going and add the stuff that it says here. If you see any of these little points, all I'm doing is I'm adding const where it says to add const. Okay, so that's where it all is. Wonderful. Now that I have this, my spaceship is ready to go. I've modified my spaceship, my properties, and let's put all these modifications up on GitHub. So I'm going to go to team. I'm going to go to changes. I'm going to say stash all, or accept all those changes. I'm going to say added properties to spaceship. Okay, commit changed, home, sync, and push. And this will give you, if you look on GitHub now, you'll see the change that I made. You can compare your code with my code. You're lost. Again, Ethan, go on GitHub, right? The GitHub link that I provided on Blackboard here, this one. And it'll take you here. And if you go to this link here, I'll put this in the chat for you. And what you can do is, if you go there and if you look at the source, and if you scroll down to what we've been working on, which is spaceship.h and spaceship.cpp, it's got all the changes right here. So anything that we've added is here, and you can compare this code with your code, or just replace your code with this code, and you're good to go. Be able to keep up like that. Okay. All right, so now that we've got this part, now that we've got the properties, I want to start modifying the ship a little bit, the ship motion. So again, I'm going to go back into spaceship.cpp, and I'm going to go into, I'm going to select my spaceship specifically, and I'm going to go down to the move function. And the move function is not the greatest right now. It was just to get us moving. And what I want to do is I want to add additional movement, right? Or more of a smooth move, if you will. And so what I need is some kind of time function. In order for me to get the time function, let's go into our main and create a delta time, because right now there isn't really a delta time, and we can decide later if we want to use it or not. But it's a good idea to have access to it just in case you want to use it later on. you know, or anything else that we've got going on, you know, so far, right? So that's kind of what we want to do. So I'm going to go back into, it does have a timer, but it doesn't have a delta time. We have to kind of create one for ourselves. So it has get ticks, but get ticks isn't what we want. So if I go to, just to show you, if I go to core, and if I go to main, which should be in core, this one, you can see what I'm doing here. In around the, this is the game loop, right? What I'm doing is I have a frame start, some kind of get ticks function, and then what I'm doing is I do a frame time is equal to get ticks minus frame start, and this is after all those things have been updated. Okay, that's what I've been doing. And so now, depending on what the frame time is, and it's some value of some number of ticks, if you will, a number of milliseconds, I want to compare the frame time that I've collected and that it's less than delta time, or sorry, delay time. And if it's less than delay time, then I want to wait. I want to use SDL's delay function. This is how the loop works. And the delay function basically goes away into SDL land and makes this whole thing wait X number of milliseconds until the delay time and the frame time match. So it's kind of frame limiting. It's kind of make it so that this thing works exactly within anywhere between 16 to 17 milliseconds on average for me, okay? And then what I do is I save the frames in the game. I'm going to kind of do the same thing with delta time, but first we need to make delta time. So the way I'm going to decide to do it is something that looks like this. I'm going to say this is delta time. We don't have delta time right now. We've never needed it. So I'm going to need it for the first time. So remember, we're making something as we need it. We're not making a game engine here. So I'm going to say that SDL get ticks. This is the total number of ticks from the beginning of the program minus the frame start, just like we had before, right? And I want to divide this by 1000, which is the number of milliseconds in a second. So I'm casting this part as a float, and I'm dividing it by a floating point number. So I'm going to get a number between 0.016 or something around there and 0.017 or 0.018, something like that. And that is going to give me my total count, right? And what I want to do is I want to set up a way, just like I did this, when I set frames, I want to be able to set delta time and get delta time. Okay, so I don't have that functionality, so let's make it. So I'm going to go into my game. I'm going to go to definition for my instance. And now I'm in my game.h, right, as an example. And in my game.h, where I have set frames and get frames, I'm just modifying my framework just a little bit, where I'm going to have something to keep track of delta time. Realistically, I would have a time class, and my time class would take care of all of that for me. Time.delta time, as an example. But I don't have a time class because I never needed one up until now, right? So, and this is how we're going to kind of work on our game anyway. We make what we need, and that's it. We don't make a game engine, we make a game. So delta time is going to be a float. We're going to say m underscore delta time. That's what we're going to call it. It's going to be a property that's a game property that we're going to keep track of, right? And we're going to set it every frame. That's what we're going to do. We're going to set delta time whether we want it or not, just like we set frames, whether we not want them or not. And it's a little bit computationally expensive, but it's okay. Our systems can handle it. And then what I'm going to say is I want a get frames and set frames. So again, you can see I haven't followed a pattern here, but let's do it. So I'm going to say, let's do a get frames first. So it's going to return a float. We're going to call this get delta time. Okay. And might as well make it const, but let's let ReSharper do it for us, as well as we want to set delta time. And we're going to set delta time with some new time. All right, so we're going to say where float is the new time that we're going to set. Okay, time is not a reserved word, so we're good. So now that we have get delta time and set delta time, let's add those in. You can do it one at a time, generate implementation, if you want as well, for those people who need to. And I'm going to do the same thing with this, just generate implementation through Visual Studio. And now I have my two function headers. And when I get delta time, I'm going to return m underscore delta time. And when I set delta time, I'm going to say that m underscore delta time is equal to time. So this is just going to set up my timer. And then what I can do with this is I can make this function const, and I can make this const as well, just like normal. So this takes care of my time function. But what I need to do now that I have my time function in place, right? So here's my time function in place, right? So first I made a getter and a setter, right? And I also have a property called delta time, which is a float. Okay. And what I want to do now is in main, after I define what delta time is, I want to set it. So I'm going to say that, hey, the game instance, and then I want to set delta time to delta time. And this is basically going to store delta time for us. Again, theoretically or realistically, what we should have is a time class that keeps track of number of frames, that keeps track of a bunch of stuff that can help us when it comes to the stuff that we're doing, okay? But we don't need that. Again, we're not building a game engine. We're just building a game right now. And then maybe in later iterations of this framework, I may add it in. Okay, so here's delta time. Hopefully that helps. And now that I have delta time, let's put it up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. And I'm going to just add those changes to game and main. Every feature, I'm adding it onto GitHub. I'm going to say added delta time, right? To game dot game.h, kind of thing. So commit stage. I'm going to say home, and I'm going to say sync, and I'm going to push this up. So this is going to push. So we have delta time now in our code. All right. So that takes care of delta time. We have this. Let's go back to our spaceship again. All right. And again, I pushed everything up on GitHub. So you can, if you're a little bit behind, go there and check to see what it does there. And you can see that I have my utility function and some changes that I made. I can go to main, sure. So here's what main looks like. All I did with main was added these 3 lines of code. One of them was a comment. So, and here what I did was I just did the same thing as frame time, but I could have used frame time, whatever the frame time was, and then, divided by 1,000. But I wanted to get the latest time by getting stl getTicks frame start minus frame start, and then dividing it by 1,000 right now after my delay to make sure that I didn't lose a part of a millisecond or whatever. Okay, so now that I've got this part, let's go back to ship.cpp, and now I have the ability for me to, to actually work with Spaceship and change the movement so it's a little bit smoother than what we had before. I don't want to keep asking for delta time, and I know I'm going to use it all the time, and it's a little long. So I'm going to say that auto delta time, just going to make a reference for it, is equal to the game, and then instance. Notice it says, do you want to add the game to the .h file, game.h to the CPP? Yeah, sure, we'll do that. Game instance, and then get delta time, right? So what this is going to do is going to get delta time every frame for us, so we don't have to fetch it. And it's going to store it in a smaller variable just called delta time. I would do this even if I had the time class. I would just do, instead of the game, it would be time instance, get delta time, and I would store it in delta time. I only want to do this calculation once. The other thing that I want to do is I want to, other calculations I want to do once are these. I've already done these ones, so I'm getting my magnitude, the direction in with magnitude. I'm getting normalized direction as well, right? And this is what we're going to change in here. We're going to change these things as an example because this is part of what I want to do. But for now, what I want to do is let's comment this out. So I don't want any changes here. I just want to make sure that this thing doesn't move and we can modify it. So let's comment it out, these two pieces. Okay, and I'm going to use delta time. Okay, I'm going to use delta time in a second. but we're going to use it later on. I'm just going to do some work on the a couple of things. So here, what I want is I want to try and figure out the target rotation. So again, let's go back here. So right now, what I have is, let's suppose I have my target. So here's my my screen, and let's suppose I have my ship that's here, and I have my target that's somewhere over here. Okay, so this is where my target is, and what I have is an orientation where I'm pointing up like this. I'm pointing up, but I really need this is my direction, but I really need to go in this direction. So this is my current orientation. So this is my, we'll call it orientation, right? Or rotation, if you will, right? So this is where I'm looking at right now. And this is my desired orientation. I want to be able to move to that location, which is the, what we put here is the target direction. All right, so this is target direction, target direction. Yeah, again, I'm just showing this in little micronized format so you understand what I want to do here. And then what I want to do is I want to get this angle. I want to get this angle from here to here. And this angle is the amount that I have to turn in order for me to point myself, redirect myself from my orientation towards my target direction. That's what I need to turn. I need to turn to this direction. Okay, so let us say that this is well, let's call it the target rotation. That's how much I want to rotate. Okay. I want to rotate this much, but I can't rotate the whole amount. I can only rotate according to my turn rate. Okay, so I want to rotate the turn rate, right? So instead of me looking up with my ship, I want to turn so I look at the target, and I want to do this over time. Okay. So again, if I run this the way it is, right, you can see that I haven't made any changes, right? And I just wanted to go back to where we were, just so you know where we're at. And so when I start this going, you can see that the ship is pointing up. That's my initial orientation, but I really want to point down this way, right down in here. And what I want to do is I want to turn my ship. I want to turn my ship down this way. But notice when I turn my ship, my orientation remains where it is. I've got to fix this problem, and I've got to create a normalized orientation based on the rotation, the degree of rotation that I'm making. So I've got to convert degrees into rotating the entire vector where I'm looking to where I want to look. Okay. So first, let's see what is my target rotation. And to do this, I can say auto. I want my target rotation. Remember, auto is just, I don't know what the type is. I want my target rotation to be equal to, I'm going to use the util function for this. Util, and I'm going to say signed angle. So the angle between from my current orientation, get orientation, to my target direction. Target direction, okay? So my current orientation to my target direction, and that's going to be my target rotation. Let's print that out. So let's just output that. So standard cout, and we'll say target rotation, right, is equal to target rotation. Okay, so I just want to print this out. So all I'm doing again is I've got my target rotation, and I'm just going to take it. I'm going to use this. I'm going to get a signed angle between my current orientation and this is going to generate that angle that I want in degrees. That's what it's going to return. Okay. So let's run this thing and see how this works. So if I run it, and you're going to see now that if I go to start, you can see that my target angle, my target rotation angle is 123 degrees. That means from where I'm looking to this is 123 degrees to the right. If I move my option right now, my ship, there's no change because it doesn't keep track of my orientation changes when I rotate my object. It rotates this, this is the number of degrees that I'm at. And if I rotate to 123 degrees, then you'll notice that I point almost right at my target. Look at that. 122 degrees here. This is what it says I should be. And I'm approximately what it is. I can't really dial 123.69 because my my float slider isn't good enough, isn't accurate enough, or discrete enough. Okay, that's what I want to do. I want to rotate this way. So what I need to do to fix this problem is I need to change my set rotation. So going up to set rotation right here on line 85 for me, right? I want to think of what I'm doing. So first of all, I change my angle, but I also want to kind of get my angle back in radians, because I want to plug in some trig functionality for this. Okay. So in order for me to use any trig functions, cos or sine or cotangent or arctangent or anything like that, some math, I need to use radians and I need to convert back. So I'm going to say that auto will say angle in radians, right, is equal to whatever the angle is that I have multiplied by and what I want to do is I have to, I also know that I have that normally our angle, sorry, going back to my diagram, this up here, and it will look, we'll look at these cardinal directions. This is north, where our object is pointing north. And typically, this north orientation isn't correct. Most of our objects, by default, they point to a east orientation to start. And this is just normal orientation for objects. So we're east is what we're looking at. So we should be, when we make our object, just to let you know, in this particular case, we should be pointing to the east, which is this way. Should be pointing this way. But we're rotated to the north, which means we're kind of at a negative 90 degrees from where we should be, because our ship is drawn that way. Now I could rotate my ship this way and call this 0, but I don't want to. I want to just, make an offset so I can subtract 90 degrees, and I can, so that wherever I'm looking is 0 degrees. This will be 0 degrees now for us. And I'm just creating an offset like that. So 0 degrees is normally here, but we're going to make it here in the north quadrant. Okay. So on that, then we have to subtract 90 degrees from the angle. Okay, just because the way I've oriented myself. And then what I want to do is I want to multiply by another util, which is a degrees to radians. So this is converting my angle minus 90 degrees to a degrees in radians, an angle in radians. And once I have my angle in radians, then I can create my two new coordinates, right? Because remember, what I want to do is I want to create my orientation. I want to set my orientation to a vector that is reflecting the angle that I'm looking at. So I'm converting the angle into a vector. That's what I'm doing, okay? And I'm storing it in orientation. Okay, so I want to convert the angle to a vector, and a normalized vector for all that. Normalized vector, and I want to store it in orientation. So once I have that orientation, then I can add thrust to that orientation. I can multiply the orientation by a value, and then I'm going in that direction. That's how it's going to be. So it's a beautiful thing, right? So first of all, let's add some coordinates. So I'm going to say auto x. So the new x coordinate is going to be, I'm going to use cosine times the angle in radians. And my auto y is going to be sine times my angle in radians. So what this is saying is, hey, I want to get my x and y coordinates for the angle that I've just calculated in radians. What is that? And whatever that is, I'm going to create x and y coordinates for those values. And this is going to create a value between 0 or -1 to 1, right, for both x and y. And then what I want to do is I'm going to take those two values and create a new GLM vec2, and I'm going to set the orientation to that. So I'm going to set orientation to a GLM vec2 where I take in the x and y coordinates and I save those values in my orientation. Sean, you need to be more specific than a syntax error. I'm not sure where your syntax error is. So again, I go one step at a time and compare my code to your code. It's up on GitHub. And then maybe you can find the syntax error. I'm not sure where you're getting the syntax error on .h. So this is, are we good? Do you understand what we're doing here? So again, I'm getting the angle. I'm converting it back from degrees into radians. By the way, it was originally radians that I converted to degrees to display it, and now I'm converting it back. Which is kind of funny that I did it this way, but that's what this does. So it takes an angle in degrees and converts it to, adds, kind of does an offset. This is the offset. If you really want to, we can put it as an offset value. So if you want to separate this because you want to modify it later, you could do something like auto, we'll call it offset, and that's equal to, a -90. If you really want to be specific, you could do it this way. And then what you can do is you want to add the offset, whatever that offset is. So angle plus the offset multiplied by its degrees to radians. And then I have my angle in radians. The reason why we have these little underscores is because ReSharper wants these to be constant. And that's my little set rotation function. Yeah, I don't know. I can show you my spaceship.h. Yeah, I'll definitely upload this. Yeah, so I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to go to, I'm going to say that I modified the set rotation function so it works with orientation. So modified set rotation so it works with orientation, right? So commit all. I'm going to go Home, Sync, and push. And that should push everything up. I'm going to just look over in the .h to see if I can help you. Spaceship.h looks like this for me. Okay, so I haven't done anything different here. This is the only part that I modified. So maybe you forgot a semicolon or something else if I do. Placing.h I haven't really touched. All I did with placing.h was, remember, I haven't touched placing.h in any way. So I'm not sure why your placing.h is doing anything. Are you sure it's placing.h? Because I haven't done anything yet. It might be something that's in here. Okay, I don't know. Let's take a look at placing.h. So that would be under scenes, and that would be under placing.h. So this is what I have for placing.h, but again, I haven't done any modifications here, so it shouldn't look any different. This is the entire class. And you should have pretty much what I have. All right, so hopefully that helps. I don't think it does, though. I think it's your problem is somewhere else. Let me go back to my spaceship.cpp now. So now that, yeah, I'm telling you, it's in your spaceship.cpp because it's being imported, or your spaceship.h. The stuff we're working on is where it is, the problem. So now that we have our set rotation to this, if I just run it, I haven't changed anything, just the set rotation function, then we should be able to reorient ourselves. And you should see the green line, actually, the green line that I've drawn, which is for the option. You can see that now you see the green line is up this way. And if I rotate my ship, so too does the green line rotate with it. And you can see now that my target rotation is 82 degrees. And if I keep rotating my ship, you can see that my target rotation is, when I get to about 123 degrees, it's about 1 degree or so. The problem with this is that I'm going to get this thing where I'm going to get this jitter happening, where it's going to go like this. It's going to try and find its way back and forth to this target rotation slowly and slowly, like this, right? But you can see what my target rotation now, and this is where my ship is pointing. That's the little debug line that I'm using with my ship. We can turn that off later. So again, I did that by just just changing the set rotation function and setting the orientation accordingly. Realistically, like I said, what we should do is we should stash the orientation inside of my transform. Because my transform has three things: position, rotation, and scale. Position makes sense, X and Y coordinates. But rotation, how do you do rotation across the X-axis? You can't, right? Because that would show in 3 dimensions, right? And you can't really rotate across the Y-axis either, right? Because you would flip over. Your ship would kind of be scaled or skewed somehow, right? So really what rotation should be is, instead of rotation, it should be orientation. It should be a rotation, a normalized vector, just like we have. And this should be your orientation, the way you're looking in normalized coordinates from 0 to 1 or -1 to 1. Okay, so that is what it should be. Let's go back down to this part now. So now that we have normalized our rotation, what if I get errors in the executable and the OBJ files? I don't see how you get errors. Have you downloaded my stuff, Nikolai? You may want to re-download my files. I'm not sure why you would get errors. You shouldn't get any errors. You copied it. Copied the scripts that I wrote? Because copying the scripts that I wrote should totally work. Because I mean, I'm just literally, you see me what I'm doing, right? So again, worst case scenario, you can take a look at my GitHub. I've modified, it tells you what I modify. Eh? So if you actually go up online and clamp and you tell, yeah. So if you look at the, lab 2B, and if I go back to this, it tells you where I'm modifying everything. So for example, see where it says modified set rotation so it works for orientation. If I go to template, then it's modified this stuff here in debug, but you don't need this stuff. This is just, some rotation that's modifying this. In fact, if anything, theoretically, I could probably in my gitignore file, ignore template, where it says template completely, because I don't need to put that up here. Same thing with bin debug. Bin debug, all it's doing is modifying the executable, the template.exe, and we really don't need the exe up online. So theoretically, that's where it goes. So you can clean project to try and do that. So normally what you want to do is you want to go here and go to build, clean solution, and then rebuild solution. And that if there's a problem with the executable, it'll rejig it. Okay. But going back to to our site here, let's go back to that. So if I go back to this, the SRC folder is where all the fun happens. And these are the things that I've changed. I added delta time to game.h. That I did, right? And this is reviewing the stuff that I did. In my spaceship.cpp, I modified, the last thing I did is I modified the set rotation so that it works with orientation. And my spaceship.h, I added properties, so those things are done. And then if I scroll down, I modified my util.cpp and my util.h and my main.cpp. These are the things that change, and it tells you when they change. So take a look at the files that changed today and modify them so that they match what I put there. Worst case scenario. Okay, so it tells you everything on GitHub. So we've done this part. We're in the process of doing this part right here, and I know it's taking us about an hour, but this is all prep that's going to pay for itself in 1 second now. Let's do it. So I'm going to go back into my move, and this is where we're going to do some better work than what we've done before. So we have a target rotation, and now I'm going to talk about my velocity, how to calculate this, and my acceleration. So let's put this back. What I want is I want to calculate my acceleration. So I want to say my get rigid body, and the acceleration now is something that I want to use as my initial orientation. I just calculated orientation, so I have a direction vector, right? That's normalized. That's between -1 and 1 on both the X and Y coordinates. And I want to multiply this by get acceleration rate. I've never set acceleration rate. We should probably do this in our constructor. So let's do this now. So this is the acceleration I've turned on, but we need to modify, at least in the constructor, set up the default acceleration rate. So let's do that here. So we'll say that set acceleration rate. Let's make it to something like 10. Okay. And we also want to, since we're here, set turn rate, let's set that also to 10, just to set some values up here in our constructor, because otherwise acceleration rate will be 0 and our turn rate will be 0. And we don't want those to be 0 for now. So now that we have our get acceleration rate, this calculates the acceleration. You take the orientation and multiply the acceleration rate as a scalar, and now you have an acceleration in the direction that you're pointing. But the acceleration isn't going to do anything until we add it to velocity. So in here where it says velocity now, we don't want this to be the velocity function. We want to change the velocity function so that it's scaled with delta time and uses our formula to some degree. So it's going to look like this. It's going to wipe this out, the velocity, and it's going to be like so. We're going to say that velocity is going to add to itself. And we're going to start with the orientation. So wherever the orientation is, that's in the same direction that we're going. And we're going to multiply by delta time. Okay, so I'm going to say, let's multiply by delta time. So, okay, delta time is right here. So we're multiplying our orientation by my delta time. Okay. And by the way, if it gives you an error, it's just Visual Studio doing its little hiccup. Okay. So that's the first part. And then what we want to do is we want to add the acceleration. So we're going to say that let's add acceleration to this. So we're going to say that we'll add 0.5, right, multiplied by get rigid body, right, acceleration, and then we'll multiply that by delta time. Now again, it's not exactly time dot time times dot time, but we're close. Okay, and we can adjust these scalar properties later on, but this is what this is going to do. It's going to scale our velocity, so it's close to what it would look like in the physics equation that I showed you here. So again, 0.5 times the acceleration initial times that time. And the reason why is, and we also have delta time being multiplied by my velocity, so times my orientation. So orientation is like my initial velocity. Comment it in the file. Oh, you mean how this works? The formula? So using the formula, so P final is equal to P initial plus velocity initial times time, right? Plus the 0.5 times the acceleration initial times time squared is what it's supposed to be. All right, and that is the formula. It's the kinematic formula that I'm using for calculating the final position based on the initial position, the velocity, and the acceleration. Okay. So this is only part of it. This combined makes that happen. So I add velocity to my position, and then, but first I calculate the velocity. I add acceleration, my initial velocity, and my acceleration to get my final velocity. All right, so this should do some magic for us. Let's take a look and see what this does for us, this little piece of code here, okay? Set acceleration, I just used 10 for set acceleration, and turn rate is 10. I haven't done turn rate yet. All I'm doing right now is I'm just trying to see if it's smoother to move my object around. Okay, let's see what it does now. So I'm going to go back to my tool. And does it give me a smoother motion is what I'm looking at than I had before. So if I start, then I get this weird thing where it goes up straight, right? And let's reset. And then it kind of goes up straight again. And it goes up straight again. It keeps on accelerating. And right now, the velocity keeps on adding and adding and adding and adding. So we need to do some changes. One thing that we didn't do is we need to clamp. And we need to clamp the, the rigid body velocity, right? we just made that clamping function, and that's we're going to do that before the position. All right. So we don't want our velocity to add forever, right? So we're going to say that, hey, get rigid body, and we want to have the velocity equal to a util clamp. This is the clamp function we made earlier, and get rigid body, right? Velocity, and we want to use max speed, which we've kind of used before. So what this does is says, hey, get my velocity and make sure that it's inside at the top rate, the top speed for the velocity magnitude is the max speed. Okay. That's weird. And if I run this thing, right? Hold on, Nicola, I'll try and fix you later. If I run this thing, then you should see that, again, it's going to go. Let's modify this so I look to the right as an example. And if I start, you can see that it's going to go in the angle that I want, right? So if I change the angle to like 90 degrees, then if I reset and start, you're going to see that it looks in the angle that I'm looking. But it's going to continue to go in that direction because reset doesn't really do the reset that I want. Not yet, not yet, not yet, Tony. It will, it will. You still get a red line in delta time. Kenny, which line are you getting a red line in? Here? 121. Oh, here. That's weird because delta time is up here. Yeah, I know there's a lot of little changes, guys. And again, if you step through it, the idea here is not that necessarily you need to clone my stuff and copy everything I've given you, but actually to understand what I'm trying to do. I'm trying to scale my movement, and I've created some structures to help me. That's all I'm doing. All right. But we're not done. When I reset, so this is where I'm going to go into my placing.cpp for a second. Okay, so placing.cpp, I'm going to scroll down. I'm going to kind of adjust it so I can go down to my GUI function that I have for IMGUI. Let's change the little window so it says what it is. This is kind of GAME3001, and it's going to be lab 2, which I'm working on. That's going to come up in the little debug window when I pull up IMGUI. Max speed is good, and orientation angle is okay. But reset's not good. Reset needs to be adjusted, and the reason why this needs to be adjusted, reset, is because it doesn't really reset anything, right? I mean, it does reset my position, but my velocity is going to run, and my orientation is going to be the new orientation. And it's going to remember those things, and I don't want it to remember. I want it to forget all those things, and I want to start fresh again, right? So in my reset little function here that I want, let's do that. So let's say that m_p spaceship, I want to get rigid body, and I want to make the velocity equal to a GLM vec2 object that's 0. I want to zero it out. Okay. So my velocity is now 0. Whenever I press reset, the reset button, it zeroes out my velocity. And then I also want to say m_p spaceship. I want to set rotation to 0.0f, which is set angle to 0 degrees. That's what this is. So when I reset, it's going to set my angle to 0 degrees, and my rigid body is going to go back to, my velocity is going to start to 0 again. Okay. There's other functions we're going to add here later, but for now, I just want it to reset. So whenever I reset, it starts at 0 and it goes back. All right. So when I run it now, I should see that my object points up on the air, and it's going to start moving. If I make my max speed low, so let's make my max speed like 2, and if I start, you can see that it moves straight up. If I reset and I change my direction, so I go like, let's say 90 degrees, and I start, then it's going to move in that direction now. So wherever I move, it's going to move, whatever angle I choose, it's going to move in that direction, right? And that's how it works now. My ship will move in any direction that I want. So the rotation actually works. This is good, all right? But I want it to rotate on its own. And that means that if I go back to the spaceship.cpp, right, then in here we're missing a piece. And the piece we're missing is we're going to calculate if my target rotation is positive, then I want to turn to the right. If my target rotation is negative, I want to turn to the left, the GUI thing. Okay, so that's in placing.cpp. All I did was I changed reset. Nikolai, are you with me too, or you still got errors? Still. Okay. I'm going to put this up on GitHub in a second. Worst case, I know this is an ugly thing to do, but what you could do is download my entire repo again, right, as opposed to copy paste and move from there, right? I know it's not the nicest thing to do. It's better to fix your problems, but maybe that's where the issue is. Something that you've put in, maybe a semicolon you missed or something, some kind of syntax. Anyway, so reset is doing this. And what I want now is I want to go back to my spaceship.cpp. I know, I'm sorry, Ethan. Your ship is no longer moving. I want to go back to my spaceship.cpp. And what I want in my spaceship.cpp is I want to change my, I want to compare my target rotation. It's a pretty simple check, but it's going to give me a little bit of jitter, and you're going to notice in a second. So I'm going to say that if my target rotation, and we're going to take just the raw target rotation, if it's greater than 0, then that means I need to turn to the right. So I'm going to set rotation. I'm going to get the original rotation, get rotation to wherever I am right now, and I'm going to add my turn rate, whatever the turn rate is. So I'm going to get the original rotation where I'm looking right now and then add turn rate to it. Okay. That's if my target rotation is greater than 0. Okay. Now be careful. See what's greater than 0? It's, of course, 0.0f is what I'm looking at, number 1. And the second thing is, will my target rotation ever be exactly 0? No. So we're going to have jitter. Okay, that's what's going to happen. Next, what about else if, we're going to say, if target rotation is less than 0, okay? Notice that I'm not saying else, because that means that it will include 0. And I don't want it to include 0. I'm going to say then that I want to set rotation, and I want to start with my rotation. And this time I'm going to subtract get turn rate, whatever the turn rate is. Now, again, there's another way to make this even nicer and so on, but we're just going to leave it like this for now because we're going to see how this works. And now, if you've done everything that I've done, and I know there's a lot of little moving pieces today, but if you did that and if I press play, then I should see something that looks like this. And now this is kind of closer to how Seek should look, except for my little jitter problem, which I'm going to fix in a second. Yeah, it kind of looks like a rocket ship on ice, but that's kind of what Seek looks like, eh? It kind of goes through, and it either passes through, it comes very close to the target, and then it switches around and keeps going forever. And that's what it should look like, okay? All right, let's reset this, and we need some more values up here in a bit. But one thing, what I want to do is to take away the jitter. What you can say is, okay, you know what? Maybe what I want is some kind of turn sensitivity. So let's add an auto. We'll call it turn sensitivity, or kind of almost like an offset, rotation offset, or angle offset. Almost like a slush or a little value where if I make that low, it's going to give me more jitter. If I make it high, it's going to look raw and rough, actually. It's going to kind of jump from one position to the other. Let's use a higher value right now of like 5, okay? So turn sensitivity is going to be 5. And I can say something like this. If my absolute value of my target rotation, right, which means I don't care if it's positive or negative, if it's anything greater than 0, if it's greater than, only if it's greater than the turn sensitivity, so greater than 5 degrees difference is what I'm saying. This is going to modify the way my functionality works. This is kind of like algorithm tuning a little bit, all right? So if it's greater than my turn sensitivity, right? So what this is saying is take the absolute value of my target rotation. So we don't care if it's positive or negative, but if it's something, if I take this and if it's greater than my turn sensitivity, then and only then do I want to turn. And what this will do is it'll smooth out the jitter up to 5 degrees. Okay, let me know, Nikolai. I'll see if there's a problem. So if I save this now with my little turn sensitivity, which is kind of turning down the, instead of me checking every single frame, I'm going to only check when the angle is greater than 5 degrees difference. And if I press play, and again, there's other ways to do this. You can smooth things with lerping and a bunch of other stuff. But if I do this, and if I go here to my lab 2, and I press start now, you're going to see that there's less jitter. And it looks a little better. Okay, that's going to keep going forever like this. And these are some basic values that I put in, but we want to give ourselves a little bit more control, right? And for the control that I want to give myself, I want to be able to give myself control in the IMGUI UI. For example, right now, if I clamp maximum speed lower, you can see that how that immediately affects what happens to my ship, how it circles around my target, but doesn't quite reach my target, right? And what about can I change my orientation angle? What if I do that? What if I change orientation? Well, by default, it does change this, but then it keeps it to this weird number, which makes this orientation angle now useless. Before it was important for debugging purposes, but now not really. Because now I can see I can literally control my ship temporarily, and then it'll send it back to where it's supposed to go. Which means that I probably want to change my orientation and revamp this back to 0 when I click reset. Yeah. All right, so let's fix this problem. So what I want to go is I want to go to my first of all, let's put this up on GitHub because I've done a lot of changes to my move function, and I think this is the final version that I'm going to give you today. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say Added Rotation to Move function, which is really what I did. Commit all, Home, Sync, and Push. And that should push everything up to GitHub. Okay, so that's kind of the move function. But let's go back into my playScene.cpp. I'm just mindful of the time, so I want to start my obstacle avoidance. And in my playScene.cpp, I want to add some additional buttons and controls to help us out. Okay, so that's what I want to do. And again, I'm also definitely interested in your suggestions if you want to add some more additional functionality and control. One thing I want to do is I've got my orientation angle, but what I want also, I got my maximum speed. Underneath that, I think I want to put my acceleration rate. So let's do that next. So static, I'll say, a float, which is acceleration rate. Let's start that off at something like 2 by default. And then if IMGUI, and then we're going to say slider float like before. We're going to make a new slider float, which is going to be acceleration rate. If I can spell acceleration rate. Here's my acceleration rate. And I want to pass in acceleration rate. And I want to start off with 0. And I want to go as high as, let's say, 50. So something insane, right? So lots of room there for acceleration. And I want to say that m_p spaceship, and I want to set the acceleration rate to whatever the acceleration rate is. All right, so that is my little slider float to control what's happening in my spaceship for acceleration only. Orientation angle can stay, although it's mostly useless now. Now I want to change my turn rate, and I'll put that under orientation angle. Let's do that. So again, static, we'll call this float turn rate, and we'll set the turn rate to 5. Let's make it 5 for now, okay, instead of 10. And if I am GUI slider float, if we start off with turn rate, we'll pass in a pointer to turn rate, and we'll say that it starts off at 0 and goes to as high as 20. Woo! So some crazy turn rate. We can give it some leeway. I definitely don't want to put 360 because that means it'll turn like on a dime, right? So 20 is good. You're going to see there's more jitter the higher it goes. And then m_p spaceship will say set turn rate to turn rate. And again, this is just adding more controls for us to debug with. And those are good. Those are really good things. Is there a way here to change when I press my reset button? I want to set my turn rate back to 5. Let's do that. So I'll say turn rate is equal to 5.0f. Okay, we want to be able to do that. I also want to set my acceleration rate to 2. So acceleration rate, I want to set that to 2. So I want to reset back to what I was. When I reset, I'm really resetting. Okay. I want to change my my speed, where it says speed here, max speed to 10. Let's set speed to 10. So speed is equal to 10. And anything else I changed should be pretty much back to the way it was. So if you can think of anything else I missed, you can let me know. But more or less, I think we've got turn rate. Orientation angle is something else. Angle in radians is what I want to do. And I guess what I want for angle in radians is to be my, I want to set the rotation because I've set rotation here. So I want to say that my angle in radians is going to be this again. So just do one of these. So I can set it back to normal. Okay, so that hopefully resets everything. Let's see what that looks like. And then I'm going to push this as well, yes. So now when I run it, I'm going to get additional little controls. And you can see how things are forming out here, right? I've got my turn rate, and I've got my speed and my maximum acceleration. And if I click start now, you can see that there's no jitter pretty much, or the jitter's gone, but it's a little bit pokey. Like it's a little bit like moving around a lot, right? And this is because of my turn rate. If I move my turn rate lower, you can see that it whaps out into oblivion land, right? Why? Because my turn rate's so slow and my acceleration is slow, like 2, right? That's not good. I can play with these numbers though. This is the great thing. So I can play with this. So I can increase my acceleration now to a lot faster. So it's going to make it so it's a lot faster. So it'll accelerate to the maximum rate. And hell, I can even make it faster, right, to 50. And you can see that it's going to turn around and around and around. Why? Because my turn rate is so low. If I increase my turn rate now, you can see that what's going to happen is it's going to have the ability for me to turn. But now I'm going to get this really weird jitter happening, especially if I approach 20. See, it's going to like turn like this, right? I can increase my maximum speed, and as my maximum speed approaches my acceleration rate, you're going to see that, or even surpasses it. You're going to see that what it does is totally turn, around and around and around, right? One way to stop this is to really choose to go our max speed down to like 0, and then you can see kind of an arrival type of thing. If I reset now, all these things reset, and I can start back to normal. But what's happened is my max speed is, even though it says what it is here, it's set back to 0. So be careful about this, as it'll keep on trying to do this kind of thing. And same thing with my some of these things, these values, right? Even though it says what they are, you can see that you can adjust kind of the values and see what it's going to do. It kind of creates different patterns. And this is a great example of kind of a seeking algorithm that has, look where you're going, all right? One more time. Let's do this. And then I'm going to push all this up to things. So if I push this up again, so the resetting is not quite perfect, is what I'm showing you. And so again, let's modify these ahead of time. So let's make our speed really low, like 3. And let's make my acceleration really high, like 10. So it's going to accelerate really quickly, but it's going to be capped at 3 speed. And let's decrease this is before I even move anything. Let's move my turn rate really low, like we're talking like 1. And see what it does, how smooth it becomes. So start, and you can see what it's going to do is it's going to go out and slowly, and you're going to see how smooth it looks. Look at that, right? As it moves around, it's going to try and reach my target, and it's going to keep doing that forever. But the problem is it's hard to reach the target because the turn rate is so low. If I increase the turn rate slowly, you can see that it's more accurate to reach my target. And now it does that funny thing where it goes around and around in circles. I'm close enough where I'm going to reach my target, but as I'm turning, I'm in a position where I'm not quite at my target, and it's going to kind of retain the distance. Okay, I'm not sure, Sean. We're going to have to debug that later on. So again, what I recommend is try and build solution, and then clean solution, and then rebuild it. Sometimes that works. So again, these are just modifying these values. If I increase my maximum speed now, let's say I increase my maximum speed, right, and I push my acceleration value higher, you're going to see that it's going to increase to the point where just the speed is going to increase because I'm kind of in a loop, right? I'm in geostationary orbit kind of. And even if I increase this to higher and higher, all it's going to do is going to go wider and wider, right? Unless I increase my angle, right? And so let's slow it right down again, right to where it needs to be, something slow. And this is the thing, as I come, if I'm too fast, I'll pass by it. If I'm too slow, I'll go right through it. And if my angle's too big, I'll have jitter. So this is where we can figure out the nice angle. And let's reduce our acceleration now value right down. And let's reduce our speed. And you can see now as we're going to approach things, it's going to get closer and closer to where we need to be until we have a nice slope. So you can see there's lots of controls we can put in place to kind of do that seeking behavior. So imagine if it's not just one object, but particles of objects, lots and lots of them. So multiple ships that are doing the same thing. And Alex may have a challenge for you guys around this by Friday, I'm sure, where he is going to modify some of these controls, change the way things work. And this is what I'm expecting from you. All right, let's push this to GitHub finally. So I'm going to go to home, and I'm going to go to changes, and I'm going to say that modified UI, debug UI settings, right? Which is really what I did. Commit all. I'm going to go to home, sync, and push. And that should be everything you need for the first part. Our first goal is met. Now the second part is us starting obstacle avoidance. And one thing is we kind of started on a good foot because what we have is a line that I drew. And I drew that line inside of the spaceship.cpp. So if you look at the spaceship.cpp, I have a line that I drew. Here's my line. And I draw from the position plus my orientation plus some 60 pixels. You can make this line as big as you want to kind of give you a bigger look. And this is just drawing a debug line. What we can do is we can turn, make a little Boolean function that turns this on and off to show the debug values only if I want to. Okay, it's up to you. Yeah, I didn't do much. I just did this. I started off with get transform position plus whatever my orientation looks like. By the way, you can change this to get orientation, which is what you should do, right? That's just the line. And you can also draw these lines at different angles. We know how to calculate an angle now, right? Whatever my current orientation is, I can calculate the new angle based on my orientation. My orientation is pointing straight forward, wherever I am. And if I want to, I can create 2 more whiskers that are one to my left and one to my right. Okay. But first, let's do some basic collision detection. And for this, I need an object. So let's make an object really quickly. And I'm going to do that here by drawing a simple object. Let's do that. So again, I'm going to pull up Fireworks, and I'm going to put this object up online for you. In Fireworks, a simple old program, doesn't matter. You can use whatever program you want. I'm going to make a brand new object that's going to be something like, I don't know, 200 by 100. And it's going to look like this, a big block. All right, that's all it is. And instead of drawing it, I'm just going to make it here. So I'm just going to kind of draw the block. There it is. And let's make it so it's exactly down here, 200 by 100 with an X and Y offset of 0. We'll make this debug block green so we can see kind of a greenish like color. So we know it's our debug block, and we'll surround it by a black border. So instead of a red border, we're going to a black border, and we'll use kind of a border size of like 5. Right, so big, thick border. And instead of 200 by 104, 200 by 100 is what I want, like this. So that is our little obstacle. Okay. And I want to save this as obstacle. So File, Save As. We'll call it obstacle.png. We need to represent it somehow. Here's my obstacle.png, and I'm going to save my obstacle inside of my downloads folder. There we go. And what I'm going to do for you guys, I'm going to put this obstacle so you can do it with me up online. So inside of content, I'm going to add a new link. So an item, and this will be called the obstacle texture, which is really an ugly obstacle, right? And I'm going to go browse local files, and I'm going to choose obstacle, and I'm going to put the obstacle PNG up there for you so you can use it. There it is. Yeah, it's really beautiful obstacle, right? And now what I want to do for me is I want to take this obstacle, which I want to put inside my assets in my textures and have the obstacle appear here. So all I'm going to do is I'm going to go to downloads, and I'm going to grab that obstacle. And what I want to do is I want to position my obstacle so I can drag and drop it way up here. Lots of downloads. I want to drag and drop my obstacle so that it's not here, but rather it's here. Okay, so this is where my obstacle is, just a green obstacle, right? With a black border. It's not exciting. It's under, Ethan, it's inside of your lab 2 folder. In labs, under lab 2, there's way at the bottom, it's obstacle texture. Okay, and you just want to put it in the assets texture folder. Now that it's there, I need a new class, and I need to quickly do this before we time out. So let's close all of this just so that I'm not distracted. So close all tabs, right? So all tabs are closed. And if I go to my Solution Explorer, I want to make a new game object called obstacle, right? So this is a great example of making a brand new obstacle. Grabbing a game object doesn't do anything, just sits there and draws. Let's make it. So I'm going to get new, add a new item. And like I said before, when you add a new item in your assets texture folder. All right, I want to make a new item, and I want to make the .h first. So what I'm going to call this obstacle, right? In the assets folder, and that's you're going to put it in the texture folder. Okay? So this one can't go in template. Template's a bad place. It needs to go in the SRC folder. So that's where it needs to go. So that is the target for this thing. So that is the target for obstacle.h. Okay. And I'm going to put that in, add, and you can see that there's obstacle.h empty. And let's immediately make the obstacle.cpp. So I'm going to add a new item, and it's going to be the CPP file. It's still going to go in the SRC folder. And we're going to call this the obstacle.cpp .cpp. And I'm going to immediately go include obstacle.h. All right, I want to do that right away so that they're linked together. Obstacle.h, which is empty right now, and obstacle.cpp, which is this one. Let's start making our file. So I'm going to say number if not defined, obstacle, right? This is how we start. Then I want to define an obstacle. I'm only in the obstacle.h right now. And then end if, I want to say that I defined it. Yay! Obstacle. And this is a guard, our .h guard, which protects us from including it twice cross-platform. That's what it is. I'm going to make a new class called obstacle, and it's going to inherit from a public display object. And it's going to ask us if I want to include it, and I do. See? I'm going to go to the obstacle class name and go to my little hammer, and it's going to say generate missing members. And I want to do that. I want to generate my draw, update, and clean functions, as well as, so these are my lifecycle functions, like what we did before. And I also want to create my constructors, as well as my destructor. So these are the things that I'm doing, plus maybe a private area just in case I want to include other stuff in my obstacle. Chances are not, right? Chances are not. And my constructor, it's going to look just like that. It's going to be called obstacle. And my destructor is going to follow suit, and it's going to just say obstacle. And now that I have these functions here defined, I'm going to go back to the obstacle name and hit the little light bulb, and it's going to say generate definitions by declaration. If you haven't got ReSharp or C++ until now, this is a great reason why you want it, because you can really scaffold stuff a lot quicker when you have this. Okay, and then I want to click finish, which is going to generate all the function headers for my obstacle constructor and my obstacle destructor. For my obstacle destructor, I want to just accept the default values for it, so make it default. And for my obstacle class, I want to turn it into something that is a final, which is like a leaf class. It's not going to be something that I'm going to inherit from. We're not going to inherit from this class to make other obstacles for now. So I'm going to prevent that from happening. So right now it's really empty, and that's all I've got. But I want to render this thing on the screen, and the way to do that for my obstacle is to, in the constructor function, load it in the texture manager. So remember, we have great examples of this kind of stuff in other game objects that we have. Again, I'm not going to start from scratch here. I'm going to just think about what my spaceship would look like if I was loading it for the first time. So I'm going to go into obstacle.cpp, and inside my constructor function, I'm going to start adding in the stuff that I would need to drive. So I want, hey, texture manager. I want texture manager instance, and it's asking me, do I want to have the instance texture manager.h included? Yes, I do. Hey, texture manager instance, I want to load the obstacle from /assets/textures/obstacle.png is I think what I called it. And we're just going to call this obstacle. And if I'm wrong, let's check. So again, I'm going to go here. I called it obstacle with a lowercase o, obstacle.png. So this is pretty cool, right? So that's when I load everything into the texture manager. I'm going to auto size it so that way, hey, texture manager, let us use the instance portal to get the texture size, which is what I wanted to do, and store in this thing. It's going to be called obstacle that I'm looking for. So I want to auto size, and I want to set the width to the size.x, and I want to set the height to the size.y. Again, maybe in future iterations, we'll do it differently than this. I want to set the type, but I don't have a type for obstacle, and for collision detection, you need one. So I'm going to go into my enums, and I'm going to go into my game object type, and I'm going to put it next to spaceship. So I'm going to say spaceship, and then next to that, I'm going to have something called obstacle. And then again, this is just for collision detection purposes. Spaceship obstacle, and this is in the game object type.h in the enums folder. And then inside of my obstacle.cpp, I'm going to set the type. So I'm going to set the type to a obstacle. So now we have some information about what this is. By default, I also want to set the position of the obstacle. So we'll say get transform and then position. And I want to say that that is equal to a vec2. By default, let's make that obstacle something like 300 pixels to the right and 300 pixels down. So 300 and 300 by default. Okay, that's where it's going to drop. If you're not, you have to include texturemanage.h at the top, Ethan. And again, I got this right away because I'm using ReSharper. Well, if you don't know displayObject.h, then that means that you're in the wrong folder. When you added your stuff, you went into a different folder. So that means that when you look at your solution folder, if I look at my, if I right-click on any one of these objects, let's say, for example, I want to right-click on obstacle.h. I'm coming out here, so I can only do this quickly. And I want to go to, I want to see this as an example on in my system somewhere, right? Obstacle.h. We know this should be in the src folder. And down in here in the full path for obstacle.h under properties, you can see that where it is. And if yours is inside of the template folder, as an example, that means it's in the wrong spot. You have to remove obstacle, and you do that by right-click, and you can remove. Not delete it, just remove. And then what happens is you can add existing. So one thing you can do is if I go back to my game objects after you've removed it and moved it physically in the operating system, you can add an existing item back into your code when it's moved into the right folder. Now, not for 30-day free trial, Ethan. What you need to do is you need to go as a student and you need to register as a student. And I kind of talked about that in one of the first videos I made. But what you can do is you can go to where it says ReSharper. So if I go ReSharper education, and it'll go to the free educational license for JetBrains, and you want to register here. And once you've done, then once you've registered as a student and you apply, then you get to use all the JetBrains products for free. All right, I'm sorry, I've got to move on. So so now that I've got this and I've done in my obstacle, I've kind of done this, I need to draw it. And in the draw function, what I want to do is call the texture manager again. So I say texture manager, and I want to call the instance draw method. And the draw method is going to draw the obstacle. And what I want to do is I want to get transform and then position.x and get transform and then position.y. And then I want to use my my rotation angle is going to be 0 because there's no rotation for now. And it's going to be 255 for fully opaque, and true, it's going to be centered. All right, so that's kind of where it's going to be at. Let's break this down, maybe like this, so you guys can see it. And that's going to be my draw function. And that's it. That is, where the draw function is. So now I can, once I have my obstacle game object, I can include it in my scene. And I've given you this again for a couple of reasons. One, you're going to need something like this. Please don't use my assets, use your own, right? But you need to have some kind of obstacle to avoid, right? So what I can do now is in my scene .cpp. So if I go back to my scenes, and if I go down to play scene.cpp, or placing.h, sorry, then let's add my new object. So I'll say something like obstacle star is m underscore obstacle. And it's asking me, do I want to include obstacle.h, which I do. And what I want to do is in my placing.cpp in the start function. So let's go into the start function of placing.cpp. Then in here, I want to put my obstacle maybe at this just after the target. So let's say target m underscore p obstacle. I don't know why it's not working. Maybe I didn't put it in properly. Placing.h m underscore p obstacle. If I name it properly, that'll be okay. That's why. M underscore p obstacle is equal to a new obstacle. This is like normal, what we've done. M underscore p, I want to, obstacle, and I want to get transform, not rigid body. That position is equal to, like it says before, we're going to accept the 300.0f and 300.0f. And we're going to add child the m underscore p obstacle. So this is the way we do game objects in our framework. And once we've done this, then I should be able to display it when I press play. So this always displays. It doesn't wait for it to be enabled or disabled, as an example. And we can make it so that it's disabled first, and then we can make it so we can turn on the obstacle if we want in IMGUI, right? Like we've done in the past. There's my obstacle. Oh man, and there's my thing. It's pretty big, right? My obstacle. So maybe what we want to do is we want to move my, my target maybe to the right somewhere. So let's do that for us. So we'll move my target now from 400 and 300 to 500 and 300. So let's say 500 and 300 and rerun it. I want to move it so that it's always to the right. There we are. And right now, we're starting our ship way out there. Let's move it even more extreme. Let's move it to like 600 and 300. Let's try that. So 600 or even 700 and 300. 700 and 300 for my target, which is going to move my target by default way to the right. And I want to move this over next to my target, right? So move it, let's say, to 500 and 300. Something like that. Right. And then when I draw my debug, right, log, and I press start, you should see that it's going to try and go right around it into the ship, and it's going to go through the target nicely because it doesn't have any collision detection awareness whatsoever. Right, but in the beginning, maybe I want to start my ship over here at, let's say, 100 and 300. Let's try that. So I want to make my ship start at 100 and 300. Everything starts at 300, like in the middle of the screen. And let's try that out. So again, when I press debug and I press start, you can see that the ship is going to go pretty much through the target. There we go. And back again and zoom through again. So every time it hits the target, it should make a collision sound, right? And this, Nikolai, you're asking for a collision manager and how this works. And we want to basically, when we go through the target, we want to detect collisions. So I have a collision manager that I built in for you guys, right? And it is under, if you look at managers, there's one called Collision Manager. Collision Manager, I've included a bunch of stuff for you. One of them is this line check, right? Line check is your raycast. That is your ray, pretty much, right? That has a line start, which is a vector 2, a line end, which is a vector 2 for the first line, and then a line start for this vector 2 and a line end, which is another vector 2. Theoretically, what I should be doing in the next version of this code is pass in a line segment class. A line segment object is what I should take as an alternate. I don't have that. I also have a line rect check. So if I want to do a check with a rectangle, then I can say, hey, give me a line and give me an AABB with the rect start and the rect width, as well as the rect height, and it'll calculate if there's a collision or not. I can also do an AABB check between object 1 and object 2. And it doesn't matter whether it's a display object or any other object, it'll just do the display object. Yes, I'll push. So I'll say Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say Added Obstacle. So commit all, right? And then we're going to go to Home, and I'm going to go to Sync, and I'm going to go to Push. Again, we're right at the end, guys. I just want to do a simple collision detection between with my collision manager, right? Now, collision manager is not singleton. It is an example of a static class, right? Similar to util, right? So I can use the collision manager simply by doing an AABB type check, right? So let's try this out. So I'm going to go back to my placing.cpp, and in the update function this time, this is new. So if I go to the update function, then in the update function where it says update display list, I can also do my collision checks. So I can sit there and say, okay, I want to do a collision check between my obstacle and my spaceship. Let's see if that works. So, or spaceship and obstacle might be the better way of doing it. So let's go to, hey, collision manager, right? I want to do an AABB check between my game object 1, which is my spaceship, so M_P spaceship, and my game object 2, which is my obstacle, M_P obstacle. So what this does is it checks to see if there's a collision. And I've built everything into my collision manager. So if I go to my AABB check now, go to definition, you're going to see that it already has some code in here, right? And what I'm doing is basically checking if object 1 and object 2 collides. There's the collision code. And what I'm saying is if my object 2 is colliding, if it's not colliding, then I want to say that it is colliding. Okay, so that's one thing we need to make sure that in my obstacle, we didn't set that up. We should set up that the obstacle by default is not colliding. So I'll say that is colliding, right? Set is colliding is what I want. How do I do that again? I have that in my game object. So if I look at, as an example, my spaceship.cpp, then right now I have a bunch of stuff here, but I've got to set that it's colliding or not as well. And just a second here, I want to make sure that I have everything because we're really timing out here. And I just want to kind of this is just for you to help you, more or less, to make sure this is working for you, so you don't feel like you've been left in the dust in terms of you're just starting off and you don't know how this works. So that's why I'm sharing this code with you. So hopefully, it's good. So I'm going to say that rigid body is colliding is false. There it is. And I want to make sure that the rigid body is colliding is false for my obstacle as well. So I'm going to say that at the bottom. It doesn't matter where you put it, but you should set that it's not colliding right now. Okay, so I'm not colliding. So going back to my collision manager, this has been set just for, as an example, I've got something called target. So I'm comparing my game object with, instead of my target, with whatever I want. Let's make it so that I'm also comparing with case my obstacle. So here's my obstacle. If I collide with my obstacle, what happens? I can say that, let's do a collision, standard C out, and I can say that collision with obstacle. Yay, right? And this is where I want to put my sound in here. This is where I make a sound to do it. And this is an example of what the sound would look like. But I need to load this sound for it to work. And I have an example of the yay sound, which is actually built in. And if you look at the target.cpp, in the target.cpp, what I need to do is I need to load the play sound, right? If I don't load the play sound for the first time, which I haven't done here, then it's never going to play the play sound or the yay sound, if you will, right? So I can use my sound manager to do that, right? So this is target. But what I'm going to do is instead of the target, I'm going to say, hey, sound manager, in my obstacle.cpp, I want to load for the first time my yay sound, right? So I'm going to say, hey, sound manager, I want to go to the instance, right? And I want to load, right? And I want to load from somewhere my file. So it's /assets and then slash. And again, let's take a look at the structure of my code, assets, and then there's audio. And then in audio, I have a yay.og sound. So I'm going to say assets, audio, /yay, yay.og. And then I got to give it a friendly name. So yay. Okay, so that is the load function that I want to use, and I got to make sure it's just done right. Instance, why is this not giving me the right thing? Sound manager instance load. Why? Hold on a second. Let's copy this. Let's cut this out. And let's go to, oh yeah. So it is this. Sorry. And I'm missing a couple of things. It's dot because I'm not using a pointer. I'm not using a pointer here. And if you hover over load, it says there's a couple things it needs. It needs the name of the file, it needs the ID, and it needs the sound type. So the sound type is an impulse sound, right? So if I type in, a sound effects, right? So if I type in sound effects, that's the type that it is, and that satisfies the requirement of loading up my sound manager. There we go. It's the way that Alex and I made it. Again, there's some discrepancies around stuff, but this is the way we put it together. Bear with it. It's not perfect. Sorry. But this loads the yay sound and stores it in the sound manager's sound, almost like a sound texture, if you will. But we need to do it at least once. And I can do the same thing as an example in another file, like, for example, the target, right? And I can store the sound here too, right? It doesn't matter if I do this. I can do this 10 times, and it won't really matter. I don't need the sound type, right? And the reason why is because it only stores it once. So now that I've loaded it, what I want is when I collide, right, then I want to play that sound. So I'm going to say sound manager, instance, play sound, yay, right? And that's going to play the yay sound when I collide with my obstacle. And it's going to also show this thing. So let's see if this works. And again, all I'm doing is I'm checking to see if I've got a collision between the sound, the object, and my manager. And it might make a really big sound, so please excuse me if it works. Start.
Yay.
There it is. Right?
Yay.
There it is. And if you can't hear it, let us modify that. Right? So I don't know if you heard that, but maybe you did. And let's go into my here. So change to my sounds. Let's share my sounds, my computer sounds. I'm sharing sound now. And I'm optimizing for video clips so that you can actually see a little bit better. So it might look a little better than what it was before. Okay, so let's just try this again, and I'll run it one more time so you can hear it. So yeah, I know it's really enthusiastic. It wasn't me. This isn't me, by the way. Someone said, "Is that you?" And I'm like, "No, it's not me." Yeah, so then if you see it,
Yay.
there it goes, and then if it comes back, it's going to do it again.
Yay.
Right there it is again, and it's going to keep going.
Yay.
At the end, it's going to keep on colliding with this thing from one thing to the other. Right there he goes. All right. So that is the little thing, and that's the first part of the obstacle. The first part of the obstacle is let's make an obstacle, and the second part of the obstacle is like, how do I avoid it now? Well, we talked about steering, and now part of what you need to do is you need to, when you're approaching the obstacle, you can use your, again, some hints for you guys to start off. here's your collision manager. The collision manager has additional functions I've given you, right? One of them is a line check, and another one is a line rec check. What you need is to use the line rec check, because if I draw a line, right, as an example, between my ship, here's my line start, and some distance ahead of myself, some line, my object, which is my rectangle, right? So this is the start of the line, and this is the end of the line. So I've got like start, my line starts, and my line ends. This can match my debug line, right? As an example, my debug line is right here, right? And once it matches my debug line, I can detect that each of my lines collide with my rectangle, and when it does, I can respond. And my line rec check, if you go to definition, is a little bit ugly, but what it does is it just checks to see if I get a Boolean. Am I colliding or not? And then you can make your own little function to do something with it. All right, so the question is, when is this due? And this is due Sunday at midnight. So right now we're sitting on Tuesday. You got some work to do. It's an individual assignment where you get to test your code. Yeah, this Sunday. It's been out for a while, right? And the next one is due in a few weeks, right? But that's with somebody else. So take a look at this. I'm going to put this up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes, and I'm going to say added simple AABB collision with ship and obstacle. Okay, and then commit all. And then I'm going to go Home, Sync, and push. Now for your lab, what all you need for your lab is something that when you show your screenshots, we want at least 3 screenshots. That's what we want. This lab is due on Friday, but the assignment is due on Sunday. So please mark your dates if I'm not wrong. Let me see when the assignment is due. Again, your assignment is due Sunday at midnight, assignment 1. And your lab is due Friday at midnight. If you're in my section, if you're in Alex's section, the lab is due by Sunday at midnight, the same time as the assignment. Okay, so 3 screenshots of what you want to do is you want to run your little lab, which is what this is. And when you run it, you want to take screenshots of different properties. So maybe you want to make sure that you can have this thing here in place, and you want to turn on I am GUI, maybe monkey with some of these controls that I put together as an example. Then you can start your thing.
Yay.
You can get a screenshot.
Yay.
Right? And then you can reset it and then make some control changes and do it again. Right? Another screenshot, maybe even show some of your code. Right? It's up to you. But those 3 screenshots are going to help Alex do the marking for him, and for me do the marking for you guys too. Miguel says, don't do more collisions. Yeah, you're right. I don't want to do too many more collisions. I'm just showing you how to do a collision. It's pretty straightforward. All right, before we go, are there any questions? We're way out of time, but I'm just here to answer any questions before we go. I'm going to stop recording. For people that are online, thank you so much for joining me. I'll see you guys next week. For those people who are here, I'm going to wait. And if there's any specific questions or people who have problems, I can go and help people out.